phase change diagram in physical chemistry and engineering technology and material science is a type of chart used to show conditions at which thermodynamically distinct phases occur and coexist at equilibrium. A real-world example of a phase change diagram is scientists would use this diagram to record the process that certain elements or compounds go through in different states of temperature. For example, a cube of ice under hot temperatures would go from a solid to a liquid and then go to a gas, while water under cold temperatures would go from a liquid to a solid. A heating curve is when the system is heated, energy is transferred into it. In response to the energy it receives, the system changes. For example, by increasing the temperature, a plot of the temperatures versus time is called the heating curve. A real-world example of the heating curves is that they can be used along with phase change diagrams to measure how much heat is being used in an experiment. Using heating curves, you can be able to see how much energy is being put in and how much heat is being put out. An input or input-output relationship.
Alright, in order to show phase change, I'm going to put ice into this pan. Alright, now we're going to put it on a hot plate. Now that we have the ice in the pot, we're going to put it on a hot plate for at least 10 minutes.
So in order to understand heating curve, we're going to solve a problem. 4.2 grams of ice is heated from negative 20 degrees Celsius to 150 degrees Celsius. What is the total amount of heat needed for this process? As you can see, I have a phase change diagram here with the x-axis labeled as time and the y-axis labeled as temperature. And here we have stages from solid to liquid to gas. In order to solve segment 1, which is the solid phase, from negative 20 degrees to 0 degrees, we're going to do Q equals mc delta T, which is going to turn out to be 42.3 grams, which is right here, of ice. So in this case, we'll be using 42.3 grams, which is the grams of ice, times 2.06 joules, which is the specific heat of water, and then 20 degrees Celsius from the change in between. So then we would cancel out the grams, we would cancel out the Celsius as well, which would leave us with 42.3 times 2.06 joules times 20, which ends up being 1743 joules. In order to figure out how much energy was used to go from a solid to a liquid, we'll be using the same formula that we used in segment 1, which was Q equals mc delta T. The m is the mass, c is the specific heat, delta T is the temperature change. For mass, we have 4.13 grams times 4.18 joules over gram Celsius times 100. The grams came from the ice, 4.18 came from the specific heat of liquid water, and then the joules, times 100, which is 100 minus 0, that's shown here. You cancel out the grams, you cancel out the Celsius, and you're left with 42.3 times 4.18 joules times 100, which equals 17,698 joules.